This is Mrs. O'Neill for AP Chemistry, Chapter 8, Section 6, Covalent Bonding, another section that is mostly review. Hopefully you watched the video from Bowen Science, Mr. Anderson. He talked about the 3 different kinds of bonds, metallic, ionic, covalent, and the only way to tell them apart really is to dig deeper into those electrons. Nice little flow chart like always. He talked about hydrogen gas and how that is a covalent bond. He talked about carbon reacting with hydrogen to make methane gas and how that can form 4 bonds. He talked about electronegativity and the trends. Again, down here with that Klumbach's law. Again, the trend of electronegativity. Fluorine having the highest electronegativity because it wants the electrons the most out of all those elements on the periodic table. Talked the difference between nonpolar and polar and how nonpolar is really going to be either the electronegativity difference of 0 or when things bond, okay, when things bond, like methane, carbon with the 4 hydrogens, and the pool of those hydrogens on that one carbon in the middle is very equal. So even though the electronegativity difference might not be 0 for carbon and hydrogen in the methane molecule, it's still going to be considered a non-polar molecule because the pool of those hydrogens on that carbon is is all the same. He also talked about this, and we will have a poggle on this to show you or to hopefully get you to understand the attraction and the repulsion and the internuclear distance. In other words, the distance between the 2 nucleus between those 2 H atoms. And he talked about how if those H atoms are too close, they're going to be too close that they're going to want to repel each other. There's also going to be what's called the sweet spot. That's the perfect spot, the perfect amount of energy. Notice it's the lowest amount of energy, and where that bond length would be between the 2. And of course, if they're too far away, they're not going to even make a bond at all. So we talked about how when that sweet spot is meant, that is going to be the perfect amount of energy, the perfect distance apart, and the perfect bond length. So what is the bond length is how far generally the atoms stay apart. Remember, these atoms are always moving. So it, again, is just going to be an average or a general an amount. And again, the bond energy is how much energy do we need to put into that bonds in order to break them apart. So a polar covalent would be, again, those electronegativities are different, or the pool is different, which means one atom is pulling more on that electron or taking that electron more often than the other. And of course, then you have that partial positive and partial negative charges. So he went through a couple of actual mathematics. He talked about the 3 different ones now, nonpolar, polar, they tend to share. The electron and ionic, of course, is going to be the transfer of electrons. So back to your packet, I'll remind you to pause the video, fill in the blanks, and then play to hear my words. The objectives in this section are to understand the molecular or covalent bonds and how they share electrons, and again, how they want to attain that octet rule. Covalent, share atoms, or share electrons between the atoms. Read over this and see if you get the right answer. Hopefully you said weaker, and there's the explanation. There's Lewis came up with this Lewis dot structure that we're going to be using. And what is a Lewis dot structure? It's just basically the dots representing those valence electrons. And you should know the groups and how many valence electrons there are in each group. And you want to know that you're going to put 1 dot on each side before we start pairing them up. So here's the trend, if you didn't remember it from Chem 1. So you might want to pull out that blank periodic table you had over the summer, or ask me for one, or put it on that nice one that I gave you, and make sure that you understand how many valence electrons are in each group. Now remember, we skip here 3 through 12, groups 3 through 12, they vary in valence electrons, so we cannot have a trend there. So here's an example of fluorine forming and water forming. So how does this actually happen? Well, you have fluorine with 7 valence electrons, you got another guy with 7 valence electrons, so what actually ends up happening is they get closer together, voila, they form that bond because now they are both sharing, and if they're both sharing, they both now obtain those 8 valence electrons because they're sharing that single bond in the middle. So you can show that by 2 dots or you can show that by a line. You also need to know the difference between a pair and an unpaired share of electrons. So we have pairs of electrons and we have unshared pairs of electrons. But you need to know the difference in that terminology. Or again, like I said, the sharing of that 2 electrons can be a line representing that bond. So in water, what happens? Well, again, read this information and I'll show you the pictorials. So, and we want to remember that hydrogen only ever needs 2 valence electrons. Okay, I would pause the video and see if you can come up with the Lewis dot structure of these 2 compounds, which should be pretty easy. Hopefully you got that. If not, you might need to rethink about valence electrons and Lewis dot structures and maybe try to find some other videos after we go through the section and practice notes and the bookwork. Multiple bonds, so we have double bonds and we have triple bonds. Of course, double bonds is sharing of 4 electrons, usually shown by 2 dashes, as you see here in oxygen, and a triple bond is showing or sharing 3 pairs of electrons or 3 dashes. Please draw in those lines. They were a little difficult for me to put into your notes, so please draw those lines as the single, double, and triple. And what happens as we increase the number of bonds between 2 atoms? Well, look at the distance, and that should make sense when we made those models of the organic, with the organic modeling kit. So hopefully that kind of jogs your memory when we made a carbon-hydrogen bond or a carbon-carbon single bond, carbon-carbon double bond, and a carbon-carbon triple bond, and you saw how those bonds that they were stretching more and they ended up getting closer together. So a single, double, triple means that you're getting those atoms closer together. The bond length decreases. Again, give it some thought and see if you come up with the right answer. Hopefully that makes sense. And again, it's going to depend on the structure of the molecules. So here we go. And in this case, we are doing more rearranging of those electrons. So we still have CO2, but we are rearranging those electrons so now that everybody is happy, forming those double bonds. See you in class.